So I'm Crina Bucur, Scientific Director of the Institute for Nuclear Research Pitești in Romania, and I will give you some thoughts about approaches for management of hazardous waste in different European member states. In my presentation, I will say a few words about the context of the study performed under Harper's project, how the hazardous waste are defined, and what are the variations in the definition of hazardous radioactive waste in different European member states. A few things about EC legislation regarding hazardous waste and regulatory context and management options for this radioactively contaminated hazardous waste, and few data regarding inventory, regulatory context, and management options for 3 of the hazardous waste selected to be investigated under Harper's: mercury waste, asbestos waste, and lead waste. And I will finish with challenges and opportunities for cross-border cooperation. It is well recognized that radioactive waste management should follow the principles of the waste hierarchy, which support the application of cross-border waste management to bring benefits to nuclear decommissioning and radioactive waste management, such as minimizing waste, increasing efficiency by lowering the cost and reducing risk of delay, and enhancing sustainability. There are challenges ahead in implementing cross-border radioactive waste management across Europe, including for radioactively contaminated hazardous waste. In the frame of Harper's Work Package 3, as David already mentioned, the member state approaches to managing radioactively contaminated hazardous waste were evaluated through a stakeholder questionnaire to which we get responses from 9 member states, from Belgium, Czech Republic, Denmark, France, Italy, Lithuania, Romania, Slovenia, and the UK. There are specific types of radioactive waste, hazardous waste, which are known to be challenging to manage via existing routes, and these were considering in the stakeholder questionnaire, mainly mercury, asbestos, and lead waste. The analysis of the responses to the stakeholder questionnaire focused on 2 aspects: exploring the variations in the definition of radioactive hazardous waste between different member states, and exploring the regulatory context and management options for radioactive hazardous waste. The term hazardous radioactive waste is used to refer to radioactive waste that, in addition to the radiological hazard posed by the inventory of associated radionuclides, it also poses some chemotoxic hazard by their chemical properties. Waste is generally considered hazardous if it or the material or substances it contains are harmful to humans and the environment. As hazardous waste pose a greater risk to the environment and human health than non-hazardous ones, these require a stricter control regime. According to the European legislation, hazardous waste are those waste which displays one or more of the hazardous properties listed in the Annex 3 of EC Directive 98. And these properties are referring to explosive, oxidizing, highly flammable or flammable, irritant, harmful, toxic, corrosive, infectious, toxic for reproduction, mutagenic, and so on, but also waste capable by any means after disposal of yielding another substance or material which poses any of the above mentioned characteristics. Analyzing the responses we received to the stakeholder questionnaire, we remarked that all member states, except Denmark and Italy, reported that radioactively contaminated hazardous waste are defined based on EC legislation that is implemented by national scale regulations. In Denmark, requirements are described in national legislation that does not mention hazardous waste explicitly, but refers to IAEA document on predisposal management of radioactive waste. In Italy, hazardous waste and radioactive waste are defined by different national legislation that are not yet linked, but a ministerial decree to coordinate the legislation is being awaited. The EC legislation, on the basis of which radioactively contaminated hazardous waste is defined by different member states, differs, but it is interrelated. It's about the EC Directive 1908, that it's the revised Waste Framework Directive applied in UK, France, and Romania. EC Directive 851, this makes amendments to the previous directive, and it is also considered in Romania. Commission Regulation number 1357 that replaced the Annex 3 of the above mentioned directive, prescribing properties of waste which render it hazardous. It's applied in Lithuania and Czech Republic. European Waste Catalogue is used in Sweden to define materials as hazardous according to their properties, and also it is implemented in the UK within the list of waste catalogue. A Commission decision 532 that details the concentration limits to classify waste as hazardous is considered in France, while EC regulation on classification and packaging of substances and mixtures is of reference in Belgium, classification of radioactively contaminated hazardous waste. Waste Framework Directive dates back from 1975 and was substantially amended in 1991 and 2006, with the current directive adopted in 2008 is the EC Directive 98. The Waste Framework Directive sets the basic concept and definitions related to waste management, including definitions of waste, recycling, and recovery. This framework directive requires that waste to be managed without endangering human health and harming the environment, without risk to water, air, soil, plants, or animals, without causing a nuisance through noise or odors, and without adversely affecting the countrysides or places of special interest. Also, the Waste Framework Directive explains when waste ceases to be waste and become a secondary raw material. The Waste Framework Directive explains how to distinguish between waste and byproducts, with the waste, of course, being the materials for further use is not foreseen, while the byproduct is a substance or object resulting from the production process, the primary aim of which is not the production of that item, and if the following conditions are met: further use of the substance or object is certain, the substance or object can be used directly without any further processing other than normal industrial practice, the substance or object is produced as an integral part of a production process, further use is lawful, meaning this substance or object fulfills all relevant product, environmental and health protection requirements for the specific use, and will not lead to overall adverse environmental or human health impacts. Also, the Waste Framework Directive introduces the polluter pay principle and the extended producer responsibilities, In accordance with the polluter pays principle, the cost of waste management, including for the necessary infrastructure and its operation, shall be borne by the original waste producer or by the current or previous waste holders. Extended producer responsibility scheme means a set of measures taken by member states to ensure that producers of products bear financial responsibility or financial or organizational responsibility for the management of waste management stages from generation to discharge. Also, the Waste Framework Directive bans the mixing of hazardous waste with other category of waste and with non-hazardous waste. The waste hierarchy generally lays down a priority order of what constitutes the best overall environmental option in waste legislation and policy. And the Waste Framework Directive introduces the 5-step waste hierarchy, starting from waste prevention, waste minimization, reuse of materials, recycling, and finally disposal, with the preferred option, of course, being preventing waste generation, and the last preferred option, sending waste to landfill. The current version of the Waste Framework Directive is the Directive 98 that established a fundamental framework for waste management in the EU with the goal to protect the environment and human health by preventing or reducing waste generation, mitigating the adverse impact of waste generation and management, and reducing the overall impacts of resource use while improving efficiency. This directive suffers some amendments. The most notable are the one from 2018, introducing broader changes to strengthen waste prevention and the circular economy, emphasizing the importance of managing waste containing significant amount of critical raw materials, and urging member states to implement measures for the collection, sorting, and recovery of such waste, taking into account economic and technological feasibility, as well as environmental health benefits. And the last one, introduced in 2023, is referred to the batteries regulations. Regarding the regulatory context and management options for the hazardous waste managed by the member states that answer to the stakeholder questionnaire, in all member states responding, wastes are classified as hazardous separately from their radiological classification. Only the response from Italy noted that a ministerial decree to coordinate the legislation defining hazardous and radioactive waste is being awaited. Radiologically contaminated hazardous waste are considered first and foremost to be radioactive waste. If a waste is hazardous and radioactive, radioactive waste regulations apply, but additional consideration of hazardous properties is required in line with regulation for non-radioactive hazardous waste. Radioactive waste regulations often specify that hazardous waste regulations must be additionally followed if the waste also presents additional hazardous properties, and that management arrangement must be no less stringent than for equivalent non-radioactive waste. In some countries, for example, France, the origin of a waste dictates its designation. For example, if it is generated in a designated radioactive waste production zone, this dictates its definition as radioactive waste regardless of its activity. Clearance of such waste is prohibited even if the material is not radioactive. This can also affect non-radioactive substances such as hazardous ones entering such zones. Apart from these points, there appear to be no great discrepancies in how radioactively contaminated hazardous waste are defined between the member states that responded to Harper's questionnaire. Examples of radioactively contaminated hazardous waste were given in a few responses. Radioactive waste coming from the nuclear facilities or activities making use of radioactive materials and containing hazardous elements or compounds, including mercury, asbestos, lead, treated water, persistent organic pollutants, aerosol cans, miscellaneous laboratory chemicals, oils and oily waste, and uranics in different forms such as uranium oxide pellets, uranium residues, uranium fuel pins, or uranium contaminated materials. The first hazardous waste considered in the study performed under Harper's is mercury waste, and for this, all member states responding to the stakeholder questionnaire consider mercury to be a hazardous waste, excepting Czech Republic. In Czech Republic, the classification as radioactive waste takes precedence over the hazardous waste, and this category of waste is classified as radioactive. Regarding the inventory of radioactive mercury waste, greater volumes of mercury contaminated waste compared to radiological contaminated elemental mercury were common to all member states responded to the questionnaire where inventory information on both type of waste was provided. The quantities of radioactive mercury waste covering both bulk metal mercury waste and mercury contaminated waste seems to vary considerably between member states, with France, Belgium, and the UK reporting the highest inventories. Regarding the regulatory context, seems to be no regulations as being specific to radioactive mercury waste. The UK highlighted EU legislation that require stabilized mercury to be disposed of in a salt mine or under deep underground rock formation, providing equivalent levels of protection. And they highlighted the challenge posed by the implementation of this groundwater daughter directive for geological disposal, which can be interpreted to preclude the direct discharge of hazardous substances, including mercury and lead, to groundwater for an unspecified type. And for this, further work to explore how this issue is addressed in other countries would be of benefit not only for the UK, but also for other member states. Regarding the management options for mercury waste, the management can be considered in two parts: the management of radioactive elemental mercury and the management of mercury contaminated waste. An established route for the management of radioactive elemental mercury was not reported by any member state. Although solidification treatments are being investigated by a few of them, such as France, Belgium, and the UK. Incineration of items contaminated with small amount of mercury was reported by France, Italy, and the UK. This route, of course, is strongly affected by the acceptance criteria of the specific incineration plant. In the absence of established management routes, other respondent countries hold their stock of radioactively mercury waste in storage. And I will detail a little bit more the management option considered in countries that responded for this waste category. For example, in France, metallic mercury, which is a liquid at ambient temperature, must be stabilized into a solid form. Radioactively contaminated mercury waste could be disposed at one of the ANDRA's near surface disposal facilities either for very low-level waste or for low-level waste. Disposal of non-radioactive waste containing mercury is only possible through an authorized hazardous waste disposal facility on the condition that the waste form respect the requirements outlined in the French government decree referring to the operational safety and for the post-monitoring safety. In Lithuania, mercury-contaminated waste that is in form of fluorescent lamps containing mercury is currently stored at Ignalina NPP. In Belgium, there is currently no established management route for radioactively contaminated mercury and for activated mercury. Decontamination via distillation may be applied for radioactively contaminated mercury, and solidification treatments for elemental mercury are being investigated. In Italy, radioactive waste containing mercury is either conditioned in cement in heterogeneous or homogeneous form, and some thermal treatment for combustible waste containing mercury was performed, and conditioning of the resulted ashes in cement matrix. In Sweden, mercury is sorted out for disposal, while in the UK, items contaminated with small quantities of mercury can be incinerated. The low-level waste repository at Donray can accept radioactively contaminated mercury that is solidified but only in small amount, and there is no available management routes for bulk elementary mercury in UK. The second hazardous waste category considered is asbestos waste, as well as for the previous category, all member states responding to the stakeholder questionnaire consider asbestos waste to be hazardous waste, excepting Czech Republic that I said they classified the waste as radioactive, since this classification take precedence over hazardous waste classification. There is a high degree of commonality in the sources of radioactive asbestos waste. This mostly is present in insulation materials and rubbles from the demolition of walls, asbestos cords or powders, asbestos containing paste, and cables covered with fire-resistant paste. The UK reported the highest inventory for asbestos waste, but it has to be noted that there are differences in the approach to inventory data reporting that contribute to the significant variation in the size of reported inventory. Regarding the management options for asbestos waste, there is notable variation for the radiological forms of asbestos waste, starting from direct cementation, thermal treatment, chemical destruction to sorting and segregation. There seems to be an inconsistent possibility for very low-level waste and low-level waste asbestos disposal. Sorry. While it is permitted in the UK, in France, of course, with specific waste acceptance criteria apply, it is prohibited in the Czech Republic, and similar variations in approaches to non-radioactive asbestos management were observed among the member states answering to the stakeholder questionnaire. Regarding the lead waste, most respondents considered lead waste to be hazardous, with few exceptions. Italy for bulk metallic lead, and Czech Republic, from the same reason, they are classifying lead as a radioactive waste rather than hazardous waste. The sources, quantities, and chemical and physical forms of radioactive lead waste varied considerably from country to country, and future construction of small modular reactors based on lead as coolant was noted as a potential future source of lead waste. Radioactive lead can be decontaminated, cleared, and released to the conventional metal industry as a common practice in certain established metal treatment facilities. Whilst approaches to management appear to be at different stages of development amongst member states, it was common for respondent countries to possess the capability to condition or decontaminate radiological lead waste either in their countries or in the commercial facilities. Around half of the member states responding to the questionnaire had near-surface disposal routes available for radiological lead disposal. This is common in France, Belgium, Romania, and the UK. But France noted that challenges in continuing to use this route if forecast inventories increase significantly, as I said, mainly from the next generation 4 reactors that are using lead as coolant. Recycling and reuse of non-radiological lead was common to all member states. However, this was only mentioned in the context of radiological lead waste by Belgium and Sweden. Well-established disposal routes for non-radiological lead wastes were also common reported, with metallic lead to be recycled to the reasonable extent. Summarizing the management options, for the mercury waste, as I said, no common disposal option for radioactively contaminated mercury waste was reported. In France, mercury could be disposed at one of the ANDRA's near-surface disposal facilities, and also the UK repository for low-level waste can accept small amounts of radioactively contaminated mercury that is solidified. Regarding the disposal of non-radiological mercury, Lithuania, Italy, and France indicated that the disposal of stabilized mercury to hazardous landfill is permitted. For asbestos waste, there is a high degree of commonality in the sources of radioactive asbestos waste. The highest inventory was reported by the UK. There was notable variation in the management options reported for the radiological forms, starting from cementation to sorting and segregation. And also inconsistent possibilities for asbestos waste disposal. As I said, it is permitted in UK and France with specific waste acceptance criteria, but it is prohibited in Czech Republic. Regarding the lead waste, near-surface disposal routes are available for radiological lead disposal in France, Belgium, Romania, and the UK. Recycling and reuse of radioactively contaminated lead waste is applied in Belgium and Sweden, but also in other countries that are sending in Sweden facility for melting lead, and I will come later with an example on this. Well-established disposal routes for non-radiological lead waste are established in all member states. And I give here an example of recycling lead from nuclear facility applications in Sweden. As you know, lead is used in the nuclear industry mainly for shielding purposes, while in the non-nuclear industry, it is mainly used in the production of batteries for vehicles. The recycling of non-radioactive lead is very common, as it has many benefits. From an environmental perspective, this recycled lead should be used for new products where possible. Recycling of lead in a context, in the nuclear context, is also working very well. By melting, almost all radionuclides are transferred into the secondary waste, either spontaneously or by applying technologies which stimulate the transfer of radionuclides to the slag and filter dust. The amount of secondary waste generated in the melting process is low, or through elevated concentration of radioactivity in the slag phase is common. Treatment of contaminated lead for the purpose of clearance and recycling has been performed at the nuclear license melting facility in Sweden. In total, more than 1,000 tons of lead have been melted in this facility for customers in 6 European countries. The resulted ingots are about 1 meter in height and each has a weight of around 1 ton. All ingots produced have either been recycled into new products or are subject to recycling upon completion of the clearance process. If radioactivity concentration in the incoming materials are elevated, the mass-specific radioactivity in the slag needs to be considered, as this mass-specific concentration may increase 2 orders of magnitude or more. There are many benefits for treating radioactively contaminated lead for eventual recycling, including recycling aligns with waste hierarchy. There is a need for lead within the nuclear industry. As I said, the new generation 4 reactors that will use lead as coolant. Recycled lead from nuclear sector is an appreciated material, and lead is a hazardous metal which is hard to qualify for final disposal. Regarding the challenges for cross-border cooperation, the main challenges in harmonizing and achieving consistency in waste inventories and achieving consistency in the reporting and management of hazardous waste between individual member states include differences in definition of problematic versus hazardous waste. The common definition of the problematic waste should be robust, not omitting any of the specific problematic waste which the country have or expect to have in the future. Issue of sharing of sensitive information, misalignment of waste categorization, issue of acceptance of the common system by respective countries, necessity of demonstration of benefits to different stakeholders, necessity of addressing the specific or general exception levels, and so on. Radioactive waste, including hazardous one, of course, is generally managed in dedicated facilities because the radiological hazards need to be managed with specific methods. The companies that are managing non-nuclear hazardous waste are generally not authorized to manage also radioactive waste. Wastes that are both hazardous and radioactive are considered in the first instance as radioactive waste and are thus subject to the relevant radioactive waste legislation. Generally, the radioactive hazardous waste can be managed in facilities dedicated for radioactive waste. Hazardous waste regulation must also be adhered to the radioactive regulations, and where these regulations conflict, the most stringent regulation take precedence. As I mentioned before, only Italy noted the development of legislation unifying the two separate regulations. Reasons for the different management options available for radioactive and non-radioactive hazardous waste were reported as owing to different legislation or their independent development and different management concepts and needs. Regarding the opportunities for cross-border cooperation, we can say that providing or utilizing cross-border treatment options appear to be feasible since all member states reported that import-export to OECD countries of mercury, asbestos, and lead radioactive waste for treatment is permitted, providing the treated and secondary waste are returned to the owning country. The EU regulation prohibits the export of hazardous non-radioactive mercury to non-OECD countries. So we can use these cross-border treatment options that exist in Europe. Czech Republic reported that the import of radioactive waste into its territory is prohibited. Although notes an exception for treatment purposes provided the waste is returned to the sender. The capability to treat and dispose of the radioactive hazardous waste that were investigated, so these three categories, is uniformly available across responding country, and the development of and utilization of cross-border solutions could provide a means of overcoming barriers to the management of these waste categories. Among the benefits of using cross-border facility, this includes the reducing the cost of treatment, encouragement of smaller waste inventories to be treated, utilizing the availability of existing technology, benefiting from variances in national regulatory policies and priorities. More generally, cross-border treatment can support the circular economy principles for a certain waste, including hazardous ones, but can also contribute to a more sustainable and resource-efficient approach to nuclear decommissioning and radioactive waste management. Thank you for listening.